Hello and welcome to this video on trigonometric equations for CSEC Maths. We'll be going through some past paper questions and also giving some tips and tricks as well as explanations. Okay, so let's get started with May-June 2013. So this is a regular trig equation, and so the first thing you're going to want to do is you're going to want to pay attention to the range of angles that they give you for your solution. So this range is basically saying that, okay, when you solve the equation and you get a value for theta, it has to be within this specific range of, for here they have 0 to 360 degrees. So that means that anything above 360 degrees will not be included in your answer, or rather it should not be included. Okay, so let's get into this equation. So as with solving any other equation, you always want to make sure that you have one variable, right? So in this case, we're going to look at the equation. It's 2 cos squared theta plus 3 sine theta is equal to 0. Well, we know that we can't exactly change sine theta into cos theta, but we can change cos squared theta into sine squared theta by using the Pythagorean identity. If you remember, cos squared theta is actually just 1 minus sine squared theta, because cos squared theta plus sine squared theta is equal to 1. So by doing that, it will allow us to actually end up with only one variable, which will make this equation solvable. So let's go ahead and do that then. So that would mean that we have 2 times 1 minus sine squared theta, since that's what we're substituting for cos squared theta, plus 3 sine theta is equal to 0. Right, so now we can just do a little bit of multiplication, and we can rearrange these variables to make it look more neat. So I'm just going to go ahead and do that. So that's going to be 2 sine squared theta plus 3 sine theta oh sorry, there should be a negative sign here, almost forgot, and then that's plus 2 is equal to 0. Let me just fix that 0. Okay, so you might be realizing that this equation actually looks a lot like a quadratic, and that's true because you can solve it like a quadratic. So what some people like to do is they like to just substitute the sine theta for a variable such as x or y, and then they come back to it afterwards and finish solving the equation. That's optional. You don't have to if you don't want to. So if you want to just keep the sine theta there, you can, but for the purposes of simplifying this, we're going to write let sine theta equal to y. So let sine theta equal y. So basically this is just to simplify it in your mind. So it's just like you're solving a regular quadratic equation, and but once you finish solving this equation, you're going to want to have to come back to this, right? Because we said y is sine theta. So whatever we get for y, that is not the value of theta. That's the value of sine theta. So we're going to have to go back and solve for theta. So just remember that step if you're going to put a y substitution. Anyways, let's solve this quadratic. So that's negative 2y squared plus 3y plus 2 is equal to 0. I don't think we have to go through solving quadratics, so we're just going to go ahead and solve this like how we know how to solve this. So negative 2 and 2 is negative 4. What's going to give us negative 4? Let's see. So that would be negative y plus 4y. So we can just go ahead and write that. So that's going to be plus 4y plus 2 is equal to 0. Then we can do some factorization here. I'm just going to take out a negative y, so I'll leave it with 2y plus 1. And if I take out a plus 2 over here, it's going to leave me with the same thing. Equal to 0. So that means our factors are negative y plus 2 and 2y plus 1 is equal to 0. Okay, so now I'm just going to draw a little column and we're going to work over here. So negative y plus 2 equals 0. That means that y is going to be equal to actually positive 2. Yep, so y is going to be equal to 2 and y is also going to be equal to negative 1/2. Okay, so now that we have solved for y, we need to figure out what sine theta, well, we know what sine theta is, but now we need to figure out what theta is. So let's see, sine theta is equal to 2. Now, if you know about the sine function, you already know that that's not possible, because the sine function has a maximum value of 1 and it also has a minimum value of negative 1. Therefore, it cannot be equal to any number that's greater than 1 or less than negative 1. So therefore, y equal 2 cannot be a solution. So our only solution here is y is equal to negative 1/2. So now we're just going to rewrite y as sine theta as we had originally substituted. So that means sine theta is equal to negative 1/2. Right, and now we're just going to solve for theta. So you solve for theta by saying theta is simply just sine inverse of negative 1/2. Yeah, okay. So if you put this into your calculator right now, your calculator is going to give you a negative number. But again, you have to pay attention to your range. And your range is 0 to 360 degrees. So you cannot have a negative, because that would be outside of your range. But what you do know is that you know that sine inverse of a positive half, right? Sine inverse of positive half is actually 30 degrees, or in radians that would be pi over 6. So if you know about the unit circle, right? So the unit circle, you know that if you go around it, you have the 4 quadrants. And in the first quadrant, all ratios are positive. In the second quadrant, sine is positive, cosine is negative, and tangent is negative. In the third quadrant, sine and cosine are both negative, but tangent is therefore positive. And in the fourth quadrant, cosine is positive, tangent is negative, and sine is negative. So if you want a negative, so if you put in theta and you get a negative value, then that means that your angle must fall in either the third or fourth quadrant if it's a sine function, right? Actually, let's just draw out a little grid up here that can help you. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So all are positive over here, so I'm just going to write all. And then over here, sine is positive, so I'm just going to put sine x is positive. Down here, only tangent is positive. And over here, only cosine is positive. So sometimes people like to make up acronyms for this, where it's like they use the letters A, S, T, and C, and they make up acronyms for it. If you want to, you can, but I usually just remember them. So yeah, so just remember, in the first quadrant, all of them are positive. Second quadrant, only sine is positive. Third quadrant, only tangent is positive. And fourth quadrant, only cosine is positive. So therefore, if we need a negative angle for the sine function, as I said earlier, that's going to be in the third and fourth quadrant. So if we know that sine of 30 is, sine of 30 is a half, then that means we're going to use 30 as our base angle or reference angle. So a reference angle is an angle that's going to be in the first quadrant, and you're going to use that angle to figure out what the other angles have to be. Let me show you how you're going to do that. So the way you're going to do that is you're going to say, okay, so if my reference angle is in the first quadrant, so I have an angle right here, and I add 180 degrees to it, I'm going to end up with an angle in the third quadrant. And if I subtract this angle from 180, I end up with an angle in the second quadrant. And if I subtract this angle from 360, I end up with an angle in the fourth quadrant. So the reason for that is because a straight line has an angle of 180 degrees between it, right? So if you want to go in a straight line, you're just going to add 180 degrees, and you just kind of figure out from there what you're going to want to do to get whichever angle. So you're just going to want to have to figure that out in your head. That's the part that can kind of be confusing sometimes if you're not familiar with it, but once you get the hang of it, it becomes pretty straightforward. So let's just work through this. So if sine of 30 is a half, so that's our reference angle, right? But we want a negative angle, or rather angle that's going to give us a negative answer when we take the sine of it. So we've already narrowed down that has to be in the third and fourth quadrant. So if I want an angle in the third quadrant, I'm going to have to add 30 degrees to 180. And 180 plus 30 is 210. So that means theta can be equal to 210 degrees. That is one valid solution. And theta can also be equal to the angle in the fourth quadrant, right? And that fourth quadrant angle is going to be 360 minus 30, which is 330. Oops. Okay. So those are the two solutions for theta in this situation. And the good thing about trig equations is you can always just check it on your calculator. So you can just type it in, and you should get a negative a half. So I'm just going to check it. Sine 210 is indeed negative a half, and sine 330 is indeed negative a half. So that means we do have correct solutions. Okay, so the next question is another trig equation, of course, and over here they're saying give your answer correct to one decimal place. So that means you're probably not going to have a pretty answer like this. It's probably going to have some decimals in it. But before we go on to that question, I would like to just quickly revisit the quadrants. So I'm going to just scroll to the bottom of this document over here. I'm going to draw the same grid actually. I'm going to go through about the angles, right? So going on about the angles, right? So we know that this angle right here is 180 degrees. So this is 180 degrees. And we know that if we go fully around in a circle, that's obviously 360 degrees. So we know these two things. So if we know that a full circle is 360 degrees, half a circle is 180 degrees, you're pretty much set. So I'm going to draw an angle right here. This is my first quadrant, of course. And let's say this angle is 30 degrees, like what we were working with earlier. Right? So I have a 30-degree angle right here. And I want to say, I want a 30-degree angle in the third quadrant. That's going to be measured right here. Oh, also one thing that I didn't say earlier. Angles are always measured from the x-axis, which is this is the x-axis, in an anti-clockwise direction. That's how you always measure angles for the purposes of your CSEC exam. Right? So, if I want an angle, so if I want to get the angle that's 30 degrees from the x-axis in the third quadrant, what I'm going to do is I'm going to say, okay, if I go around to the x-axis on the other side over here, that's 180 degrees, right? Since I've gone 180 degrees already, and I want to go 30 more to get to this angle, then all I have to do is add 180 plus 30. So that's how you'd get to this angle. But let's say I didn't want to go so far. Oops, I erased the axis. If put that back. So yeah, let's say I didn't want to go so far, and I actually just wanted the 30-degree angle in the second quadrant. Right? So if I wanted this angle, again I'm gonna think, okay, if I was to go fully from the first to the second, that would be 180 degrees. But I'm not going fully there. I'm stopping 30 degrees short. Right? So if I'm stopping 30 degrees short, that means I have to subtract 30 degrees from 180 degrees, which leaves me with 150 degrees. So that's this third and second quadrant, but let's say we're in the fourth. The fourth is a little bit different. So the fourth, we have a 30-degree angle, again with the x-axis right here. So I want to get this angle. So if I want to get this angle, I have to go more than 180, but I have to go more than the third quadrant as well. So I wouldn't really want to use those two, but what I would rather do to save time is I'd rather say, okay, if I go fully around the circle, right? Let's just draw a nice little arrow going around. Fully around the circle is 360 degrees. But again, I've stopped 30 degrees short of 360 degrees, which means I can just calculate this angle by subtracting 30 degrees from 360, which is 330. So that's how you get all the angles in different quadrants. You just have to remember about you just think about it like going around in a circle. And however far you have to go around in the circle, you just reason it out from there. But always start with your reference angle in the first quadrant, because then once you have your reference angle, you can actually figure out any other angle you need to figure out. So let's say we have actually a 60-degree angle. Right? So the 60 degrees is our reference angle. And now we want to get an angle in the third quadrant. Or rather, since I used the third quadrant earlier, let's say we want to get an angle in the second quadrant. So if we want the angle in the second quadrant, that's 60 degrees when measured from the x-axis. So that's what we always mean. So the reference angle is always taken from the x-axis, as all angles are measured from the x-axis. So if we want the angle that's 60 degrees from the x-axis in the second quadrant, we're gonna do the same method. We're gonna go around the full rotation, which we know is 180 degrees, right? So this full rotation here is 180. And since we stopped 60 degrees short of 180, we're gonna subtract it from 180, and we're gonna get 120. And then for the third quadrant, again, same method. Think about the rotations. So if you want 60 degrees from the x-axis in the third quadrant, we go 180 degrees, but we're going 60 degrees more than 180 degrees. So we simply have to add 60 degrees to 180, which is of course 240. And then for the last quadrant, you want 60 degrees measured from the x-axis again. You know that a full rotation of the circle is 360 degrees. And of course, if you stop 60 degrees short of 360 degrees, that's 360 minus 60, which is of course 300. So again, it's just about the rotations. Just think about having an angle in the first quadrant and just rotating it around the circle, and it will come to you. It will just come to you naturally. But if you don't really want to do that, and you actually just want to remember things, let's just draw out a short little formula. So I'm going to draw these angles. I'm not going to give them a specific value. I'm just going to call this first one, which is of course the reference angle, theta. So that means if I want to get this angle, it's going to be 180 minus theta. And if I want to get this angle, it's going to be 180 plus theta. And then if I want to get this angle, it's going to be 360 minus theta. So these are the formulas to calculate the angles. They're there, but I suggest that you try and remember it for yourself, just because in case you forget these formulas and you have to figure it out in the exam, you'd know how to do it. Let me just label all the quadrants. So I'm going to label them with the letters as well. So A for all, S for sine, T for tan, and C for cosine. Of course, this means all is positive, sine is positive, tan is positive, cosine is positive. Okay, so we might reference this diagram in later questions, but let's get back to it. So this equation now, again, we want to pay attention to our range, 0 degrees to 360. Okay, we know that. And then we're going to do the same steps, and we're going to make sure that we only have one variable. So this time we have a cosine theta that we know we can't change, but we have a sine squared theta that we can change, so we're just going to go ahead and do that. So we're going to substitute 1 minus cos squared theta. That's of course equal to 5 minus 10 cos theta. So now I'm just going to rearrange the variables in the same way I did above. So 8 cos squared theta, and that's going to be plus 10 cos theta. Eight times 1 is 8. 8 minus 5 is positive 3. So this is what our equation would look like when we finish transposing everything. Let's just make sure. So yep, negative 8 cos squared theta plus 8 minus 5 is positive 3. Minus 10 goes to positive 10, and that is indeed our equation. Okay, so all we can do is we're going to do the same thing. This time we're just going to say let cos theta, of course, because we're not working with sine. Let cos theta equal to y, and then it's just solving a quadratic, which you've been doing since like third form, so that should be pretty simple. 10y plus 3 is equal to 0. Factoring this, negative 8 times positive 3, that's negative 24. So you can use negative 2 and 12 to get 10. So let's just go ahead and write those in. Negative 8y squared minus 2y plus 12y plus 3 is equal to 0. Okay, I'm going to factor out a negative 2y, which is going to leave me with 4y plus 1. Let's fix this 4 so it's a bit more clear. It doesn't look good. And then that is, we're going to factor out a plus 3 over here, which means that's going to be, again, 4y plus 1 equal to 0. So then our factors now are going to be negative 2y plus 3 and 4y plus 1. Is equal to 0, of course. Okay, doing the same thing that I did above, going to write the column. So what are our values for y? If we transpose, we're going to get y is equal to 3 over 2. And y is equal to negative 1 over 4. So again, 3 over 2, that's greater than 1, so you know that that cannot be an option. So that's not a valid solution. So our valid solution is y is equal to negative a quarter. So of course, we're going to undo our substitution, and we're going to say cos theta is of course equal to negative a quarter. And then this one, again, we're going to do the same thing, but I'm going to actually work this one a little bit differently. The reason why I worked this one up here like this is because we should know that sine theta, that when you have sine of 30 degrees, that's a half, because that's one of the angles that CSEC requires you to know. But here, this is a quarter, so we don't actually know how to work this out. What I'm going to do is I'm going to write ref. So I'm going to write ref, which stands for reference, because I'm going to say the reference angle, which is just ref theta, is equal to cos inverse of a positive quarter. So I'm just doing this for the sake of not getting confused. So if I put cos inverse of a quarter into my calculator, I'm going to get 75.5 degrees. So remember I said this is the reference angle. This is not what theta actually is. So to get theta itself, what we're going to have to do is we're going to have to visit our quadrants, and we're going to have to use that to figure out what our actual value should be. So where is cos negative, right? That's what we're looking at, because we have a negative quarter. So where is cos negative? If you remember from the quadrants, cos is negative in the second and third, right? Because sine is positive here, tan is positive here, cos is negative here and here. So if cos is negative in the second and third, that means our value for theta has to be in the second or the third quadrant. So using 75.5 degrees as our reference angle, that means theta can either equal to 180 degrees minus 75.5. So we're going to write that 180 minus 75.5, which is equal to, let's just type it into the calculator, that's 104.5 degrees. Or theta can be equal to 180 plus 75.5. Because remember, these are our formulae for the second and the third quadrants. And if we just quickly type that also into the calculator, that's going to be 255.5 degrees. That's not a 2. 255.5. degrees. Okay. Oh, one thing you should probably do is indicate that these are your values for theta, because as you can see, the working out can get a little confusing. So you should indicate what your final answers are, so your examiner has a bit of an easier time figuring it out. Okay, so that's number 2. Number 3, we have an instance where we're gonna have to use sine squared theta plus 3 cos 2 theta, right? So we're gonna have to use the double angle formula for cos, which, if you remember from last time, will have, last time being of course the trig identities video, cos 2 theta has multiple different ways of being written. So let's see which way is going to be most beneficial for us here. So our other variable is sine squared, right? Which means that if we're rewriting cos 2 theta and we're going to want only one variable, we should use the version of the formula that only has sine in it, which is of course 1 minus 2 sine squared theta. So we're going to substitute that into our equation. That's going to be sine squared theta plus 3 times 1 minus 2 sine squared theta is equal to 2. So now we only have one variable, so the rest is just some algebra. So let's go ahead and do that. 3 times 1 is 3, 3 times negative 2 is negative 6, negative 6 plus 1 is negative 5, so that means we have negative 5 sine squared theta plus 3, because 3 times 1 is 3. Oh, made a mark. And then that's equal to 2. So that means we can rewrite this as, just do some transposition really quickly. 2 minus 3, if we bring the 3 over to the other side, that's going to be negative 1. Negative 1 divided by negative 5 is of course 1 over 5. But we're not done here, because we're going to have to take the square root. So we're going to have to say, let me just write it here actually. So we're going to root this, we're going to root this, which means that sine theta can either be equal to positive 1 over root 5. Oops, let me fix that. So yeah, positive 1 over root 5, or sine theta is equal to negative 1 over root 5. Because if you remember, when you square a number, no matter what sign is in front of it, it's going to give you a positive number. So if you take the square root and you have a variable on the other side, that variable can either be a negative or a positive. Right? And of course, the square root of 1 is 1, so that's why I didn't bother writing the full fraction under the square root. I just wrote 1 over root 5. Okay, so now it's just the same thing. So we're just going to say sine theta is equal to sine inverse of 1 over root 5. Okay, so if sine inverse of 1 over root 5, right? We can just plug that straight into our calculator. And we get, let's see, 26.6. So that is actually one of our solutions for theta. Our other solution for theta, however, if you remember, because sine is positive in the first and second quadrants, will lie in the second quadrant, right? So that's our other solution. Because if you put in that angle, then that means you're still going to get 1 over root 5 for your answer. So you remember that for the second quadrant, the way that you solve for the angle is 180 degrees minus your reference angle, which in this case would be 26.6. So that gives us 153.4 degrees. Again, it says to 1 decimal place, so I'm putting these to 1 decimal place. Oh, actually guys, you know what I forgot? That I've been telling you all this time. I forgot to check my range. But my range this time is actually in radians. So instead of putting it in degrees, what I'm going to do is I'm going to actually write it in radians. Now, you don't exactly have to do this, but it's a nice touch, you know? If they give you the range in radians, it's good if you give them the angle in radians. So you know how to convert degrees to radians? You're gonna multiply by you're gonna multiply by pi over 180. So it's going to be pi over 180 multiplied by 26.6, which gives me, instead of 26.6, that's gonna give me 0.5. 0.5. Some people use this little like small c to represent radians. I like to use that. Other people use rad, so you can 0.5 rad, or you just write out the word radians. Just indicate that you're using radians though, because it's good to have. So for the other angle now, which is going to be also converted to radians, that is 2.7. Okay, so these are angles in radians. So we have two solutions so far. So now looking at the other one, I'm going to go ahead and tell you from now, we don't even have to work this out. And you're probably wondering why you don't have to work this out. But again, it's because of our range. Look at our range. Our range is 0 to pi. And if you remember, pi in radians is actually 180 degrees. But where is sine positive? Sine is positive in the first and second. And where is sine negative? In the third and fourth. And of course, the third and fourth quadrants, if you look back here, are past 180 degrees. Therefore, neither of these angles are going to be within our range, so we can simply say that there is no solution for this. I'm just going to put no solve. So then we have actually finished our question already. So we have 0.5 and 2.7 radians. Okay, for this last question, I'm going to have to erase this diagram that I drew here, so you can have space to work it out, but I'm pretty sure by now you guys are all familiar with the concepts of the quadrants and all the angles, etc, etc. Okay, so this one is May, June 2022, which is pretty recent, and I'm not going to make the same mistake I made last time. I'm going to look at the range first. So our range is 0 to 2 pi, so this is in radians as well. 0 to 2 pi is 0 to 360 degrees, so we have a full rotation of a circle. Alright, let's get to solving it then, shall we? So we have cos 2 theta plus cos theta plus 1. So now cos 2 theta and cos theta we can't work with those as they are. As much as it seems like we can, and we can just add it together and get cos 3 theta, no, you cannot do that. That's not how that works. So we're going to have to rewrite cos 2 theta in terms of cos theta. And how we're going to do that, we're going to use one of our identities, and one of our identities is of course 2 cos squared theta minus 1. So that's going to be really helpful for us, because that's going to get rid of this positive 1 over here, and it's also going to allow us to work with one variable. Also, I think this question has a little bit of an error. It should say all of that is equal to 0. That's our bad, we forgot to put that in, but yeah, so just pretend that there's an equal to 0 there. So we're just going to make the substitution, so that's going to be 2 cos squared theta minus 1, but we already know that that minus 1 is going to cancel with this positive 1, so we're just going to leave that out. So that's just going to be that's going to be 2 cos squared theta plus cos theta is equal to 0. Because obviously if we had written that minus 1, it would cancel with positive 1 over here. So for this one, I'm actually not going to do the substitution step, because this is actually a really simple equation. So I'm just going to go ahead and factor out a cos theta, and that's going to leave me with 2 cos theta plus 1 is equal to 0. But no, we cannot divide out this cos theta, because then that's going to get rid of one of our solutions. We actually have to let that stay until we finish solving everything. Just a quick side note, just in case anyone was thinking that you can just divide it. No, you cannot, just to be safe. So that means we have 2 possible solutions. Either cos theta is equal to 0, or cos theta is equal to negative a half. Right? So these seem like they're both valid, and that's because they are both valid. So we can just go ahead and start solving. So for this one, let's work on this one first. That means theta is of course cos inverse of 0, and cos inverse of 0 is, I believe, 90 degrees. Is there another angle that's going to give us 0 though? So before we work on the other angle, I'm just going to write this. I cannot write 90 degrees because they have asked for the angle in radians. So I'm actually just going to give them in radians. 90 degrees is pi over 2. So let's just write that. Pi over 2 is one of our angles. And our other angle, let's see, is there another angle that is going to give us that? And I believe there is. And that angle would be 270 degrees, which in radians I'm going to calculate in a second. So that's going to be pi over 180 times 270, which is 3 over 2 pi. Actually, did I say 3 over 2 pi? My bad. That's 3 pi over 2. Let's not get that mixed up. So yeah, these are 2 of our solutions for theta when cos theta is equal to 0. So cos theta equals negative a half. So again, we're just going to go ahead and work this out. We know we're going to have, it's a negative, so we're going to have to use a reference angle. But in this case, of course, our reference angle is going to be 60 degrees. Why? Because cos of 60 degrees is a half, and 60 degrees in radians is pi over 3. So that's, we're working with that as a reference angle. But of course we need a negative value for theta. And where is cos negative? Cos is negative in the third and second quadrants. So that means our value for theta has to be in the third and second quadrants. So I'm actually just going to work this out in radians. However, you could work it out in degrees and change it to radians for your final answer, but that's up to you. I'm just going to work it in radians. So our reference angle is 60 degrees, aka pi over 3. So for our first angle, which is in the second quadrant, we're going to just go pi minus pi over 3, which is 2 pi over 3. And our next angle is going to be pi plus pi over 3, which is the third quadrant, of course, which is 4 pi over 3. Let me just put the symbol. Oh, that's a bit too large. Okay, so now we have all 4 angles. You'll notice that this one's a little bit different because this one actually has 4 solutions. Usually CSEC doesn't give 4 solutions, but they can. And this is one of the cases that they have given it. So if it has so much solutions, it's usually good to kind of just write them out as like a little therefore statement. You can say therefore theta is equal, and then you just go ahead and list off all of these angles. Some people like to be really neat and they like to list these in order. But I guess we can do that because why not? So that first angle going from smallest to largest is pi over 2, then 2 pi over 3, then I believe it's going to be 4 pi over 3, if I remember correctly. 4 pi over 3, and lastly 3 pi over 2. So these are all our solutions for theta, and you notice that all of these are within our range, which is 0 to 2 pi. So that wraps up all of our questions on trigonometric equations. Yes, they can be a little bit confusing sometimes, but really and truly, if you remember about your quadrants and you remember about your angles, and just be careful, again, I can't stress it enough, please look at your range that they give you, because otherwise you'll be throwing away free marks. And of course, remember that you always want to get one variable, so you're going to have to make your necessary substitutions sometimes. And again, just pay attention, stay focused, and they'll work themselves out. So yeah, thank you for watching today. Hope you've learned something or picked up something you didn't know before. And yeah, see you guys in our next video.